Hi there, hope you have a fantastic day today. This lesson I will teach you how to add and subtracting vectors. Of course, there's a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. So let's say we have two vectors. That is vector, let's say u is equal to, let's say a1 I plus b1 j, and then another vector that is vector v is equal to a2i plus b2j. So let's say we plus v and u together. So u plus v. So this means that we're just gonna add a1i plus b1j. We add a2i and then we add b2j. So now we just add the I components together and the j component together. So that is a1i add a2i and we add b1j with b2j. So if I take the common factor out for I component and j component, so that will give me a1 plus a2. And this is I component, and this is b1 plus b2. This is for j component. This is in vector component form. Or we can write in column notations. So that is u, vector u plus vector v will give me a1 plus a2, and then this is b1 plus b2. There you go. This is vector u plus vector v. How about u minus v? So for u minus v, similarly, so u we have a1i plus b1j, and then we minus, so a2i b2j. So now the I component, which is minus it, so that will give me a1i minus a2i and plus b1j, and then we minus b2j. So we use the I component, we minus the I component, and for j component, we just minus the j component, okay? So I can take the I component out, so that become I1 minus I2 plus B1 minus B2, and this is j component. So of course, this is vector component form. So I can write in column form. So that is also u minus v is equal to a1 minus a2. And then this is b1 minus b2. There you go. So if we add vectors together, the I components, we just add with the I component. And the j component, we add together. Similarly with the subtractions. So the I component, we minus the I component and the j with the j, okay? So keep that in mind. How about scalar multiplications? So let's say we have vector u is equal to, let's say, ai plus bj. So multiplied by a scalar, let's say k. So therefore, which is k times that. So if we expand this out, so that is same as k ai plus k, we time together, kbj. Of course, we can write in column form. So if we have u is ab, that's a vector in column form. And if we multiply by a scalar, which is k, and we multiply this, so this is the same as ka and then kb. There you go. Let's go through a couple examples. So first one. So let's add the two vectors together. So vector OA plus vector OB. So let me just write this down. So that is equal to 3, 5. We add -1, 3. So remember, we just add the I components together. So that is 3 plus -1. So that means 3 minus 1, which is 2. So that is 2. And then the J component, that is 5 plus 3. So 5 plus 3 is 8. So the answer is 8. So OA plus OB is 2, 8. Now OA minus OB. So OA minus OB, let me just write it out. So 3, 5 minus -1, 3. So we just minus the I component. So that is 3, -1. So 3 minus -1, so which is 3 plus 1. So 3 plus 1 is 4. So that will give me 4. And the J component, which is 5 minus 3. So 5 minus 3 is 2. So there you go. So OA minus OB is 4, 2. Now -3 OB. So -3 OB is -3 times OB. So OB is -1, 3. So if we times together, so the -3 times I component and -3 times J component. So -3 times -1. So that will give me 3. And the J component, so -3 times 3. So -3 times 3 is -9. So that is -9. There you go. Second example. So we need to find the value of A and B. So 2 -3 is equal to A, 4 plus 6 -B. So this means that for I component, so A plus 6 is equal to 2. So I just write this down. So 2 is equal to A plus 6. So just solve the linear equation, that's all. So I just move the 6 on this side, becomes -6. So 2 minus 6 is 4. So therefore, A is equal to 4, negative. There you go. And then we have the J component. So -3 is equal to 4 plus -B. So in another word, 4 minus B is equal to -3. So we have -3 is equal to 4 minus B. So therefore, I just move this -B on this side and -3 on that side becomes positive. So B is equal to 4 plus 3, which is 7. So therefore, A is equal to -4 and B is equal to 7. There you go. Please pause the video and try this one yourself. Hi, I'm back. How do you go? So let me go through them with you, okay? Before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into it. So first one. So 2OP is 2 lots of 3, 2. And we add OQ. OQ is -3, 1. So before I add the two vectors together, I need to times the 2 for OP first. So that is 2 times 3, which is 6. And then 2 times 2, which is 4. So 6, 4. And we add -3, 1. So 6 minus 3, which is 3. And then for the J component, 4 plus 1 is 5. There you go. Now 3OP minus 3OQ. So that is equal to 3 lots of OP which is OP is 3, 2. And then we minus 3 OQ. So OQ is negative 3 and then 1. And before I subtract them, I just expand it first. So that is 3 times 3 is 9. 3 times 2 is 6. So we minus. So 3 times negative 3 is negative 9. And 3 times 1 is 3. So I just minus it. So it becomes 18. And this 6 minus 3 is 3. There you go. Last one. Please pause the video and try it yourself. Hi, I'm back. How do you go? So let me go through it with you. So let me just write it out first. So which is 2a minus 3 plus 3 for b is equal to 6, 9. So I just expand it out first. So that give me 2a minus 6. And add 3 times 4, which is 12. 3 times b is 3b. And that is equal to 6, 9. So the I component is 2a plus 12, which is 6. So I just move the 12 on that side. So we just solve the equation, that's all. So 6 minus 12 is negative 6. So 2a is negative 6. And then we divide by 2 on both sides. A is equal to negative 3. Then for j component, so that is negative 6 plus 3b is equal to 9. So negative 6 plus 3b is equal to 9. So I just move this negative 6 to the right hand side. So that becomes 9 plus 6. So 9 plus 6 is 15. So 3b is equal to 15. So I just divide by 3 on both sides. So that means divide this by 3, divide by this by 3. So therefore b is equal to 5. So therefore we have a is equal to negative 3 and b is equal to 5. Thank you so much for watching. I hope you got all of them correct. Bye.